Hello everyone, I'm Miss Canal, one of your grade 11 maths teachers. In our previous lesson, we introduced numeracy, and numeracy covers a lot of numbers in the number system. We actually looked at surds. In today's lesson, we would look at indices. Indices is the plural for index. What does it mean? In mathematics, we look at indices as a power. For example, it is written as a to the power of x is equal to y. A to the power of x is equal to y. X is the index. Indices is the plural. A is the base, x is the index, and y is the result. In numeracy, we have, and generally in mathematics, we have a lot of laws, rules, and properties. The same here in indices, we've got 6 basic rules or laws that we need to look at. And we'll go on straight to it. We'd look at law number 1. And law number 1 says, if a raised to the power of m, and you multiply that by a raised to the power of n, their common base simply means that the base are the same. You keep the base and you add the powers. You keep the base and you add the powers. This law only applies if the base are common or the same. Let's give a numerical example. In a numerical example, supposing I have 3 raised to the power of 2 or 3 squared, and I multiply that with 3 raised to the power of 5, it simply means they are the same bases, so I keep the base, which is 3, and I add the powers. Raised to the power of 2 plus 5, which gives me to 3 raised to the power of 2 plus 5. It simply means it is 3 raised to the power of 7. And the result, that means that you multiply the base 3 by itself 7 times. And the final result of that would give us a product of 2,187. That is indices law number 1. Let's continue on. And let's look at indices law number 2. In indices law number 2, we still have the same base, a to the power of m divided by a to the power of n. That means that the fact that it is a common base, what we do is this: we keep the base and we subtract the power. When it is multiplication, we keep the base and we add the power. In division, we do the opposite of multiplication and we subtract. Let's look at a numerical example. And we have a numerical example of, if the base is 4, it is raised to the power of 8. It is divided by 4, again, raised to the power of 5. The fact that the bases are common, we keep the base, which is 4, and what do we do with the powers? We subtract. So that would give me to 8 subtracting 5, and that would give me to 4 raised to the power of 3. What does that mean, 4 raised to the power of 3? It simply means you multiply the base 4 by itself 3 times. 4 times 4 is 16, and 16 times 4 gives me a product of 64. So that gives me to rule number 2, or law number 2, I should say, of indices. Let's continue on and look at the third example. And the third law gives me to, if I have a base m, and it is raised to the power of m is a number. So that would give me to all of that raised to the power of n. We have application of indices and its rule in multiplication, in division. In the third, the law gives us that if we have m raised to the power of m, all of that to the power of n, it simply means you just keep the base, and what do you do with the powers? You multiply. And that would give you to m raised to the power of mn. Note, if there is no multiplication sign on pronumerals, it means multiplication. Let's look at an example. And in example number 3, we have a base 5, all of that squared or raised to the power of 2, and that would give me to all raised to the power of 3. What does that mean? It simply means you keep the base 5, you multiply the powers, 2 multiply 3, and it gives me to 5 raised to the power of 6. That means you multiply 5 by itself 6 times to give us a final product. Remember, the term product is used when you multiply. And it gives us to 15,625. That is the final result. Let's continue on. And we continue on to rule or law number 4. It gives us a raised to the power of 0. The value is 1. What does that mean? It simply means that any number at all in the counting system, for as long as the power is 0, its value is 1. Let's give an example, and I'll give an example. If 4 raised to the power of 8 divided by 4 raised to the power of 8, I am going to apply law number 2. I keep the base, and what do I do with the powers? I subtract. And that would give me to 4 to the power of 8 minus 8 is equal to 4 to the power of 0, and its final value is 1. Any number. 1 million raised to the power of 0, its value is 1. That's this law. Let's continue on to rule or law number 5. And in rule number 5, we would have A is the base, and the power is a negative. If a base is raised to a power of a negative number, you always write it for as long as one thing that we need to know, that the value A here is not equal to 0. Any number, but it must not equal to 0. A to the power of negative m is equal to the reciprocal of that, and A to the power of positive m. What is a reciprocal? A reciprocal is a term that we describe a number that is turned upside down. For example, 2. The reciprocal of 2 is a half, 1 over 2. In this case, then, the reciprocal of A to the power of negative m is 1 over A to the power. In the process, the negative m changes and becomes a positive. Let's look at a numerical example. And in a numerical example, we would get 6 raised to the power of -2. Okay? The reciprocal of 6 is 1/6, meaning 1 over a denominator 6. Over 6. In the process, this becomes a +2. That would give me to 1 over 6 squared is equal to 1 on a denominator of 36. It becomes a fraction. That is law number 5. In law number 6, and the final law, basic law of indices, we will now use the nth root of a to the power of m. In our previous lesson, we looked at surds, and we used the radical sign. This symbol here is, in mathematics, is called the radical sign. So, if that is so, let's express that in the form of a fraction. If that is the case, a is still the base, the n becomes the new denominator, and the m becomes the numerator. Okay, if I were to give an example, maybe we could really see what it means. If I have the cube root of 8 squared, the cube root of 8 squared simply means that I can write it into an index form or indices. It would look like this here. So it would be 8, the 2 becomes the numerator, right? The 3 becomes the denominator. That is the third root of 8 squared. Then we could rewrite it back to try to solve it. What is the value of that? So the value of that would give me to the cube root of 8, all of that raised to the power of 2. What does it mean by the cube root of 8? It simply means that, what is that number? When you multiply it 3 times, it would give you to 8. The result would be 8. The answer is 2. 2 times 2 gives you a product of 4. 4 times 2 gives you a product of 8. So the cube root of 8 is actually 2. So when you get 2, note it is raised to the power of 2. Your final result then, 2 multiplied 2 is equal to a product of 4. I keep using the term product. Product is the result or the outcome when you multiply any two numbers in the counting system. And we have just concluded the 6 basic laws of indices. In our next lesson, we will be looking at exponential equation. Exponential equation is simply comes back to application of these laws that we just studied. I hope you have enjoyed this lesson. We'll see you again. Bye-bye.